Hi, welcome back. So you've seen OWL same as, and again, we'll talk about what linked open data means in more detail next week. But in brief, you've seen how to connect two different knowledge graphs with each other. You've also seen properties. These are core part of RDF. And in OWL, you can be a lot more precise about these properties. You can say if a property is symmetric, transitive, functional, inverse functional, reflexive, irreflexive, and so on. So things you know from logic or math, you can precisely specify in your knowledge graph. You can also say if a property refers to data or literals. So you can have object properties, and then the object must be a URI. And you can have data type properties, meaning that the range, the object is a literal. For example, you can say that in FOF, there is an email, and you can define it as inverse functional, meaning that two different people cannot have the same email address. So the email address is a functional property for the person. So the FOF email, you would define it as a data type property, which has the inverse functional property. And then if you encounter something like this, you have the definition of this email, and you find that an object A and an object B have the exact same email, then using an OWL reasoner, you can say that URI A must be the same as URI B, using this inverse functional property relationship. You can also define inverse relationships between properties. You can say, for example, that an author is the inverse of author of. And then when somebody is an author of something, then the inverse is automatically concluded as well. This often helps because in the graph, all the nodes are directed, the edges are directed between the nodes, and very often you want to traverse them in both directions. And then instead of defining all properties twice, like author and author of, you just define one and say that the other is the inverse of. You can do a lot more with classes as well. In RDFS, basically all we can do is saying that one class is a subclass of an existing class. In OWL, you can actually construct classes using other classes. You can say that the union of two classes is a new class, or the complement of a class is another class, and this can be arbitrarily complex. So going back to what I said earlier, this is basically a logic language, and the logic is DL, a description logic. Description logic is, again, a whole family of different logics, and they all have names that are based on the features that you are using. So it's a bit like, in software terms, like a library. You can import different features, and depending on which feature you import, you have a different kind of logic. And for all of these logics, people know in detail how efficient it is to reason with this kind of logic. So basically, if you need more features, more advanced reasoning, you can add these to the logic you want to use, but then you have to pay with more processing time for the reasoning. And for very large OWL ontologies, this can be impractical for certain applications. So it's kind of a trade-off between expressiveness of the logic and the time you need for making automated reasoning conclusions. You might also see this kind of notation in the context. So for description logic, you can say, for example, literature is defined as the union of novels, short stories, and poetries. So this is a notation that you'll see, for example, in books or in research publications. And this is specific to description logic, and the implementation in an AI system using OWL would use the OWL language. So just like RDFS vocabularies, there are a lot of ontologies that are using OWL. So, for example, medical ontologies have used OWL since the very beginning, but there are also lots of other ontologies. But biomedical ontologies are certainly one of the most widely used ones because they started very early. They had very early on the problem to integrate all this knowledge that you have from biological experiments, genomic data, and so on. And they needed sophisticated ways to analyze and connect this data. So this is one of the earliest domains that adapted this kind of ontology-based reasoning. Okay, so much for the quick review. And in the next part, we're still in introduction, we'll talk about the main topic of today, the queries. See you then.